All right. The first thing we're going to do here is we need to label our triangle. They want to know what X is, right? And now this, we haven't done one like this yet today. If X is missing, is that an angle or is that a side? You might want to look at the book. It's probably easier to read that. It's a side, okay? Now, I can use my trig to find this missing side also. I can use it to find missing angles, or I can use it to find missing sides. What I basically need to do is set up the little trig fraction, and then just solve it out. So let's see what happens here. Let's label it. Here's the 32-degree angle right here. So I'm going to label from that angle because that's the angle they gave me. What is X in this triangle? Is it opposite, adjacent, or the hypotenuse? It's opposite that 32-degree angle, so let's put OPP on it for opposite. Now we know the hypotenuse is always across from the right angle, right? So that one's was an easy one to label. There's only one side left. What does it have to be? Adjacent. Yeah, it's always most of the time people wait and do that one last. And of course, it is next to the angle. It's the leg next to the angle, so that you can kind of double check that you did it right there. All right, so I want to find the X, and that's the opposite side. And where the number that I have, isn't it on the hypotenuse over there? I have a hypotenuse of 10, and I want to know the X, and the X is the opposite side. So what I do, this is how I need that SOHCAHTOA memory device thing. If I write SOHCAHTOA down, remember the S, the C, and the T stand for sine, cosine, and tangent. And the other letters, the last two letters, tell me how to build my little fraction of sides. Which one of these has opposite and hypotenuse in it? Is it SO, CA, or TOA? Which one has an O and a H in it? So, right? Okay. So I know I want to use this one right here. So I need to say, okay, it's the sine, and it's always, what goes here is always the angle. So this is the sine of 32 degrees. And SOHCAHTOA, the SO part says that I put the opposite on top and the hypotenuse on the bottom. I usually come out to the side and do that just to make sure I get my stuff in the right spot. The opposite side goes on top, and the opposite was the X that I didn't know, right? What was the hypotenuse that's going to go on the bottom? See how I wrote it over here so I could find it pretty easily? It was the 10. Oops. 10. Okay, so here's what I have. I have sine 32 degrees is equal to X over 10. Now I have a little equation I can solve. I want to get X by itself, right? You know what? Don't I have a fraction on one side? And wouldn't it be really easy to make this into a fraction, the sine 32, by sticking it over 1? That's a proportion, isn't it? How do you solve a proportion? Cross multiply. Let's do that. 1 times X is X, that direction. And then if I multiply this other direction, I get sine 32 times 10. Now here's what I want to tell you to be careful about. Don't write down sine 32 times 10. Put the 10 out front, because if you write down sine 32 times 10, what people accidentally do, and they don't mean to do it, they just accidentally do it, is they might type in sine of 320 in their calculator. It just happens. It's like something almost everybody does it sometimes. So when you got a trig function and you got a number you're multiplying by, it usually works out better if you stick it out front so that you don't accidentally think it's part of the stuff you're supposed to plug in for sine, okay? Well, I can type this in my calculator. I can just pick my calculator up, and I'll stop this for a minute because I'm getting X equal, let's see, what we got on the calculator now is about 5. I'll put down some digits, 29919. What should I round that to? Yeah, so what's X? It's about 5.3 units long. That's how long that side is. So I can use the trig functions to find missing angles or missing sides. It's just kind of like you see, well, what's missing? Is it a side that's missing, or is it an angle that's missing? And that determines what you're going to do. Okay, so this is another one. Number 24 is another one where they're asking me to find a missing side. Sometimes I find the angle, and I do that with that inverse button with whatever trig function I have, but here they want a side, so I'm still going to go ahead and build that little fraction. What's the first thing I should do? What have we been doing first with these right triangles here lately? We always do what to them first? Label. Good, label. Here's the angle. You got to find the angle because you got to label from the angle. Across from the 66 degrees, that's going to be my opposite side. Do I have anything over there? Is there any number or X or anything? No, so that's probably not going to be anything I'm going to use, okay? Now, the other easy side to label is the hypotenuse, and that's this right here, isn't it? Ooh, I got a hypotenuse of 45. Maybe I want to write that down just so I can really, keep up with what information I have. Oh, that's not a degree. It's 45. It's not a degree. I just wrote that down out of habit because we just got through doing those triangles. What does that mean, this side down here where the X is going to be? What is that going to be called with the labels? That's the adjacent. Good, adjacent. So let me put ADJ over here. Okay, so A for adjacent and H for hypotenuse. What I'm going to do now is go and write down SOHCAHTOA. And eventually you get to the point where you don't have to do this. I'm just showing you what people do when they're getting this stuff down here. I'm looking for the one, I know that S is sine, C is cosine, and T is tangent. What I'm looking for is which one of these has an A and an H in it. Which one do y'all see that has A and H in it? Yeah, this one right here. Do you see the A and the H in it? So what does that mean? That means the cosine of some angle, I'll just put a theta there, the cosine of some angle is its adjacent side over its hypotenuse. Okay? So this is what I'm going to use to make my little equation that I'm going to solve. Do I know my angle in this situation? What is my angle here? I actually gave me that, didn't I? It is 66. So let's put it right there. The angle always goes either right after the sine, the cosine, or tangent. That's always where you put it. All right? Cosine is adjacent over hypotenuse. I'm going to write an A over H over here just to guide our thinking. What was the adjacent side again? It was an X, wasn't it? See how it's got the X on it? And my hypotenuse was 45. I could either look back over here where I labeled it, and sometimes as I would go when I was first learning this, I would actually write it over here just so it would make it easier. I wouldn't have to go back to the triangle. The hypotenuse was 45. Now, I'm missing the side. I know what the angle is. That's cosine 66. I can stick that in the calculator and just hit COS 66, enter, and it would give me that long decimal. But you know what? It might be easier if I just let the calculator multiply everything instead of me having to write that down. Most people don't like writing down that long string of numbers and then multiplying it by 45. So let's do this. I have a fraction on one side. Let me make cosine 66 into a fraction by sticking it over 1. And what am I going to do now? I've got a proportion that I can solve by cross multiplying, right? So here we go. 1 times x is x. And then on the other side, I'm going to cross multiply, and I'm going to say cosine 66 times 45. But because I know you've kind of been warned that people mess up, let me put the cosine 66 there, and let me put the 45 out front just so that I don't accidentally type in cosine 6645 or something weird like that. Or sometimes people will write down, if they wrote it this way, sometimes I'll see people do this, times 45, and you know what they do is they go multiply that together, and then they take the cosine of that number multiplied together, and that's not what we're supposed to do there. We're supposed to be multiplying 45 times whatever the cosine of 66 is. Okay, so I'm going to go in my calculator. I'm going to multiply this out, so I'll turn the video off for a minute when I put that in the calculator. I got like 18.303, if I'm reading that right from here. Blah, 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 blah. So if I'm rounding to the nearest tenth, that would be about, what, 18.3? My missing side is about 18.3. Okay, so we're missing the angle, so that means I'm going to label from that angle because I'm trying to find it. So from that angle, I know that this is the hypotenuse, right? Did that have a number on it? Doesn't have a number, doesn't have a variable on it. I'm probably not going to use the hypotenuse at all. And remember, the reason I'm doing this is because in a minute I'm going to need to come over here to SOHCAHTOA and figure out what trig function I can use to solve this problem. So I label first. Let's see, here's the angle. The opposite side would be, if an ant crawled across to the opposite side of the triangle, he'd end up over there where the 16 is. Opposite. For some people, that's the hard part. They don't see that that's opposite, but hopefully by now y'all do, because we did the 45-45 90s and the 30-60 90s, and we had to label opposite angles. So hopefully that's something that's a little easier. And that means that that 9 over there has to be what? Adjacent. There's an opposite, adjacent, and hypotenuse, and I'm messing that up writing it down. So here's what I have. If I kind of look at what I have a 9, and that's adjacent, and I have a 16, and that's the hypotenuse, and I have a missing angle. Oh, yeah, sorry, thanks for catching that. I get so busy writing, I forget. And I'm missing the angle, and the angle that I'm missing is x, right? Okay, so I know I have an a. I need to look for the trig function that has an a and an o in it. Which one has an a and an o in it? TOA, right? What does this t stand for in TOA? Yeah, it's the tangent of the angle, and I'm just going to write it like this at first. The tangent of the angle is its opposite side over its adjacent side. This is what 11.4 was about, but see how they've tucked it in here too. It's going to show up in here too, because these things just, you know, they can label any sides they want to, and you just choose a different trig function. Well, I don't know what my angle is. That's what's missing. So I'll put the x there, won't I? It's tangent of x. That's the missing angle. What was the opposite side? It was 16. So we'll fill that in on the fraction. And the adjacent side, we labeled that, and it was 9. Okay, so see there. Now we've got that set up. If I cross multiply here, I'm not going to get anywhere much because what's missing is the angle. So this is what we started with today, because this is it's kind of, you know, people have a hard time sometimes with this more than the other ones. If I want to find a missing angle, I need to undo the tangent to get down to that x. The x is really kind of by itself on one side. It's just caught up in the tangent function. So what I'm thinking, like if I'm thinking in terms of algebra, is how do I get rid of the tangent? Well, I do the opposite of the tangents here. It is the what? The inverse tangent. Yay! Right? Just making sure you're with me there. So I'm going to take both sides, and I'm going to do the inverse tangent to both sides. It's kind of like adding 3 to both sides. Or square rooting both sides. Okay, so now what did that do? These two things cancel out. They undo each other. They're called inverses or opposites. So what I have left is x is equal to the inverse tangent of 16 over 9. And so this is something I type in my calculator. And just to remind you how you do it, you hit second tan, because above the tan button is the tan to the, it looks like tan to the -1 button. That's really inverse tan or arctan, okay? And then all I'm going to do, the calculator's going to open up a parentheses, and I'm going to type that fraction in there, 16 divided by 9. So what I'm going to do now is shut off the video and go do that on the calculator. So I rounded my angle from the calculator, and it is about, so I need to put those squiggly signs, 60.6 degrees because I'm working in degrees.